Hello and welcome to my video of accelerometer data analysis. Today we'll try to use accelerometer data to predict physical activity intensity levels. So to get into the details, let's take a look at the data set. In our data set, the variables are here, like you see that mean, variance, max, mean. Basically, these are all summary statistics of different axes. So when you're using accelerometer devices, they capture acceleration along the three axes, and these feature set is actually the summary statistic of those three axes, which is x, y, and z. And here you can see the individual data of sex, age, height, weight, and cause intensity, which where the cause intensity is our target variable, which is sedentary, light physical activity, moderate physical activity, and vigorous physical activity. You can also see that there are some missing values here, so we need to make sure that we clean those observations. So basically, what the data means is for the sedentary level, your summary statistic of your acceleration along the three axes are these data, and these are some demographic, these are some individual characteristic data of the individuals. Also in the age variable, there are some problems with, like, the minimum is 18, but the maximum is 1569. So this age error will be corrected using another data set which was performed by the same individuals, which is our 2B data set. Here the individual's age was 29, so we will correct that age in here also. And also, since the accelerometer was placed on the heap, that's why it's written heap here. So first, to remove the missing values, we set missing values as NA. That's how the Azure machine learning program will learn that those are missing values. Using the missing values scrubber, we will remove the missing values. Like, we will remove the entire rows of the missing values and keep the columns. Then in the edit metadata, what we'll do is we'll transform cost intensity and sex into categorical variables here. And in the R script module, what we will use the R code to change the ordered response of our variable, since ACD, LPA, MPA, BPA are ordered response, and also correct the age variables by substituting these values with 29, uh, these values with 29. So this is actually a good way to incorporate various other modules like R or Python into the Azure ML environment. The next up, we select the columns. Basically, we select all the columns in the data set and run the model. So in terms of choice of the model, we have selected a multi-class decision forest. Basically, a forest is building lots of individual classification trees and aggregating those results. This is actually an ensemble method, and here we train the model, and using the test data set we will score the model. Now if we take a look at the score of the model, we can see that what the model did is calculate the probabilities of different classes for 1, 2, 3, 4, and assign the class with that has the highest probability, which is 1, 6 to 5. So this is how the full data set has been calculated, and in the evaluate part of the model, uh, we will see where view the confusion matrix, and the confusion matrix gives us a good view of where everything went wrong. Like for the models here, you can see that most of the errors occurred in adjacent categories. Like for 2, which is light physical activity, the model made errors mostly classifying this class as ACD. And also similarly goes for all other classes for MP and PPA. You can see that the adjacent categories have more classifications there. And also among the 4 classes, ACD was the most successfully classified among all these 4 classes, and the overall accuracy is actually 63%. Seeing the confusion metrics, we can at least assume, we can at least come to a decision that the model is actually not that bad because most of the errors are in adjacent categories. It's not like the model is classifying most of the observations from PPA as sedentary. That would be more and more wrong. So the model is actually very good. Thank you.